Okay, everybody, we are live. Hey, it is Friday. What is it? June 16th. I have about, what time is it anyways? It is noon my time, and we have a very special event for you guys today. We have Mr. Kent Hovind and, oh, hang on, I just did a no-no. I thought I'd turn that off, but we have Kent Hovind here with King Crocoduck, and they're going to have a little debate on some of the merits of evolution versus creationism, I believe, is the topic. I am just hosting this. I will moderate if needs be. I will time check if needs be, but basically this is going to be between both of them. I do want them to introduce themselves a little bit, so if you're not familiar who they are, they can tell you all about themselves in a few minutes, and then I think they have some opening statements prepared, and then we get right into the actual debate itself. So Ken, I'm going to let you go first. You want to tell a little bit about yourselves, and then we'll go to Casey.
Well, sure. Thank you. It's an honor to be here. I object to your description of it being evolution versus creationism. I think it's evolutionism versus creation. The ism should go on evolution, but aside from that minor detail, let's see. I was a high school science teacher, science and math for 15 years, moved to Pensacola in January of '89, and soon thereafter began a ministry titled Creation Science Evangelism. I believe the Bible is literally true and scientifically accurate. The earth is about 6,000 years old. God made it in 6 days. That's the only way things work with so many millions of symbiotic relationships. And as far as we've got history, we can talk about the age of the earth later. But I defend the position that the Bible story of creation is correct, and the flood story is correct as written, and there's going to be a coming judgment one day, and we're all going to stand before the creator of the universe, and you better get ready for that day. So that's my position.
Okay, thank you, Kent. And what about you, Casey? You want to tell everybody a little bit about yourself as well?
Well, I'm a researcher right now in computational biophysics. I got my degree from UC Santa Barbara. I have research experience in astrophysics. I dabbled a little bit in quantum field theory, but right now it's basically biophysics, a little bit of medical physics, and integrating a little bit of nuclear physics in there as well. I'll go more into detail about my actual position during the opening statement, but basically I'm generally in agreement with the majority of the scientific community when it comes to issues like the age of the universe. I take it to be 13.8 approximately billion years old, and I do not accept the creation myth as believed by my opponent.
Okay. Do you care who has the first opening statement?
I didn't go first. If it doesn't matter, I'd like to hear what he has to say first.
You or me?
Go ahead. No,
go ahead. Casey.
Okay.
I believe that you want first. Go
ahead.
Right
then. I guess
I'll give him the same amount of time you have. So.
All right then. Though my training has been in physics, and though I've come to this debate with the understanding that the matters being discussed will exclusively pertain to the physical rather than biological sciences, I'd like to open with a little bit of philosophy of science. Mr. Hovind and I are in serious disagreement over the circumstances of the universe's development, and though I labor under no delusions that I will manage to convince him to change his mind, I've come here today to demonstrate before a live audience that Mr. Hovind's entire worldview is at variance with the very fundamentals of science. That is not merely to say that my opponent misunderstands the rudimentaries of the theories that he denies, which is patently obvious to those of us who work in the relevant fields. I am making the much stronger claim that Mr. Hovind does not understand the nature of scientific discovery, or how theories are developed and selected, or how the scientific enterprise as a whole functions. And so I'd like to open with an observation that may at first appear to be trivial. That is, that the most remarkable thing about science is that it works. It consistently produces reliable results that have revolutionized our species in a way that no other way of thinking ever has. 1,000 years ago, humanity's capacity to communicate was limited by the amount of parchment that your bird could carry, and by the distance that it could travel. Now we can instantly send terabytes of information to people on the opposite side of the world via invisible beams of light. 1,000 years ago, we envied those birds and their seemingly limitless freedom to explore the world and reach places that we couldn't. Now we pity them for being constrained to a fraction of the heights that we've reached. 1,000 years ago, we sacrificed those birds and inhaled their sacred fumes in order to fend off the demons who we believed were responsible for the plagues that nearly wiped us out time and time again. Now we are the predators of the microscopic organisms whose devastating effects we once attributed to the supernatural. Science works. Hate the method for being so rigorous, hate the conclusions for not conforming to your expectations, but do not deny its power. Science is not perfect. It's a self-correcting enterprise, but it is ruled by some of the most rigorous standards possible. There is simply no other method of inquiry that can compete with science when the goal is to construct accurate models of reality. The method that has allowed you to watch this debate and hear my voice is the same method that has been used to construct the theories that creationists deny. That these other theories haven't had as much of an impact on our day-to-day activities as, say, quantum theory and germ theory have is irrelevant. The strength of a scientific theory is determined by how consistent it is with reality, and this consistency can be measured in terms of how well the theory fits with current data, and especially how accurately it predicts future data. That is the central point that I wish to make in this opening, for creationists, and indeed all pseudoscientists, will attempt to subvert the scientific principles that they reject by ignoring this essential fact. It is extremely important to always keep in mind the importance of predictive accuracy and potential falsifiability, because this is how we distinguish science from pseudoscience. If a model makes testable, potentially falsifiable predictions with parsimonious explanatory power, then it may be worth your consideration. If all that a model has, however, is ad hoc speculation that incorporates selective data mining and unfalsifiable remedies to fundamental problems, then what you're dealing with is a perversion of the scientific method. I put it to you that my opponent and his contemporaries indulge in the latter while attacking the former, and that they do this out of the misguided belief that science operates in a manner akin to a court of law. Mr. Hovind has made comparisons of this sort on a number of occasions, and he epitomizes this sentiment when he makes the claim that creationists and so-called evolutionists are all looking at the same evidence, but are led to interpret it differently because of their philosophical predispositions. Unbeknownst to him, however, this is effectively an open admission that he is engaging in pseudoscience. He does this so that he can put the disciplines that he tolerates and the disciplines that he does not on a level playing field in order to gain a tactical advantage during a discussion. A person who knows how to navigate the arena of public discourse can make a seemingly powerful case to the uninformed, even if this person knows almost nothing about the topic under discussion. This is what lawyers get paid to do. Their job is not to try to determine the reality of the situation, but to present a convincing case. A prosecutor and a public defender can look at an identical set of evidence for a given case, but the arguments that they present will be diametrically opposed because they have been assigned their conclusions from the outset. Suppose a suspect is put on trial in a criminal court. In principle, two lawyers could enter the room and flip a coin to decide who defends and who prosecutes. It does not matter to either of them whether the defendant is actually guilty or not. What matters is whether they can convince the judge of their a priori conclusion. Even if a lawyer doesn't mentally accept the position that they represent, there is nothing that can stop them from nevertheless presenting their case, if they so choose. Scientists, on the other hand, cannot operate like this. A scientist cannot flip a coin to choose which side of an academic issue they accept. Where the lawyer is assigned a position and uses the evidence to synthesize a model that defends that position, a scientist's judgment must remain unimpeded. All available evidence is interpreted within the appropriate context, meaning that no extraneous, unfalsifiable assumptions need to be made, and that evidence is synthesized into a model with predictive capabilities. There are no a priori conclusions in science. Maxwell didn't assume the equations of electromagnetism, he derived them to correspond to observation. Einstein didn't assume that time slows down for objects in relative motion. He calculated this result as being a natural consequence of the invariance of light speed. Physicists didn't assume that the Higgs boson would have the specific properties that it did, and they calculated those properties, its spin, its charge, its threshold energy, and so on, decades before by studying the properties of symmetry breaking. Where a good scientist will suspend judgment until they have a reliable model of a phenomenon, creationists openly admit that they do the exact opposite. They begin with their conclusion and selectively piece together whatever evidence helped them construct a convincing narrative of events. This often involves distorting key facts, and always involves the omission of contradictory evidence. Creationists feel justified in doing this because they project this behavior onto their opponents, asserting that everyone's presuppositions will determine their worldview. But scientists don't interpret evidence in a manner that fits an a priori conclusion, and this is what separates them from lawyers. By arguing that creationists and so-called evolutionists are looking at the same evidence but interpreting it differently, and that both positions consequently deserve equal consideration, those who hold to the same evidence, different interpretations paradigm are unwittingly admitting that they are being lawyers and not scientists. So how are we to distinguish, then, between two competing models of reality? How are we to decide which theory ought to be discarded, and which ought to be provisionally accepted as the best model in the light of the available data? The answer, as I've indicated, lies in the properties of the theory itself. It must make testable predictions that are independently verifiable, potentially falsifiable, and parsimonious. To say that a theory is not parsimonious is to say that it contains extraneous elements that compromise the model's explanatory efficiency by incorporating components that limit the scope of its predictive power. And to say that a theory is not independently verifiable and falsifiable is to consign it immediately, in the Popperian sense, to the catalog of pseudoscience. It is my position that Big Bang cosmology, stellar evolution, radiometric dating, and a whole host of other principles at the center of astrophysics, nuclear physics, geophysics, and mechanics are all situated within theoretical frameworks that not only meet the criteria for scientific rigor, but have enjoyed tremendous success with regard to the prediction of future data. Because ultimately this is what it comes down to. The scientific near consensus about these matters is valid because mountains of data have been accurately predicted, often decades in advance, by the very models which Mr. Hovind would have us believe do not work. The models may not be perfect. None are, as science makes no pretensions to perfection, as it is driven by the pursuit of explanations of inconsistencies and ambiguities. But the models nonetheless work, as evidenced by their stunning predictive capabilities. I will show you today that they do indeed work, and that my opponent's models are at best ad hoc rationalizations of pre-existing knowledge or vaguely worded text, and at worst, indications of a disturbingly superficial grasp of the concepts on which he pontificates. The laundry list of arguments against the models that you have set yourself against does not constitute an understanding of the scientific theories that you deny. And worse, because scientific theories are effectively entire networks of interrelated observations, laws, predictions, and principles, it is impossible to do what Mr. Hovind does without serious consequences. There are consequences to picking and choosing, cafeteria-style, the kinds of science that one is willing to accept. I will show you today that the consequences of denying the constancy of the speed of light, of denying the validity and temporal uniformity of radiometric dating, or of denying any number of other fundamental principles in science, results in models of the universe that are patently absurd, even to a creationist. Whatever our disagreements, Mr. Hovind, we at least agree that we're not being inundated with lethal doses of radiation from quickly decaying isotopes in the Earth. We at least agree that the sun exists, having successfully met the conditions necessary to engage in fusion at the core. We at least agree that the universe is not an endless sea of particles haphazardly floating about. But these are the kinds of consequences that would follow from the rejection of the scientific principles which stand in the way of a 6,000-year-old universe, and I will elaborate on them if and when they come up. What makes science, including the scientific models that creationists deny, so unique is that they are capable of making independently verifiable, potentially falsifiable predictions, whereas all that creationist models are capable of doing is providing a potential explanation, constructed ad hoc, for already existing data. Anyone can do the latter with any preconceived conclusion and a selective set of evidence, but only scientists can do the former. Any and all creationist claims will, without exception, fall at least into one of the following categories. It will be based on a misunderstanding or misrepresentation of the scientific enterprise or any relevant scientific principles. It will be based on an unreasonable or inconsistent standard of evidence. It will contain vague terminology that allows for equivocation and goalpost shifting. Or if we're fortunate enough to be dealing with an honest creationist, it will be an acknowledgement that a belief in creationism is dogmatic rather than evidentiary, and therefore can never under any circumstances be changed because contradictory evidence will be arbitrarily discredited or ignored. Before I close, I would like to make a prediction for this debate. I predict that whenever I corner Mr. Hovind on any matter, demonstrating how the rejection of a particular phenomenon results in the vision of the universe that is patently absurd, my opponent will claim, without evidentiary justification, that the variables under discussion or the principles being rejected used to be different, that the laws of physics, for whatever reason, changed over time in such a manner as to make the universe appear to be billions of years old rather than thousands. I'm going to give this retreat into unfalsifiable omphalism a name. In honor of my opponent, I shall name this practice Hovinding, and I will point it out as we go along. Creationism by any reasonable metric is pseudoscience, and I intend to demonstrate that for all of you today.
Okay, thank you. So you're about 15 minutes, including that little disconnect that you had. Ken, take as long as you want your opening statement. I know you wanted to address certain points, obviously, specifically. You had mentioned to me when Casey was offline. Go ahead and do your opener first, and then you go ahead and address things specifically, because he did have a 15-minute long opener. Is that fair?
Oh, sure, whatever time you want. Yeah,
okay.
Very easy to please. Well, thank you. He said, as I mentioned to you when he was off air, maybe he couldn't hear us. I think we certainly, with this important of a topic, need to take it one slice at a time, one sentence at a time maybe, or sometimes one word at a time, but certainly one thought at a time. In his opening, he probably brought up 50 or 60 different topics. I'd like to respond to each one of them, but obviously I can't write that fast for one to get them all down. But I'll be glad to respond to any of them that he would like. Now, I take the position that the Bible is literally true and scientifically accurate. God made the world in 6 literal days about 6,000 years ago. Now, as far as where God came from, that I cannot answer, just like I doubt KC can answer where the matter came from, or the energy came from, or the laws came from that run this universe. Where did these laws come from? You know, to say it's inherent in the matter just begs the question, where did the matter come from, or energy, or information? But that's another story. But I don't, we both have an a priori assumption of something, starting with something. I start with God. And I take the position that God is outside of time, space, matter, like he says he is. He told Moses, you tell Pharaoh, I am sent you. God is not, this is not 2017 in heaven. God has already been to your funeral, Casey. He's not limited by time at all. He sees it all at the same time. Now you have an option of what you want to do with your life, and you can choose anything you want, and so do I, so does everybody. But I would encourage you to really think this through, because you're going to be dead for an extremely long time. And if I'm right, I would suspect you're in serious trouble. You said about the strength of a theory is that it depicts reality. And it predicts, makes predictions, and it's falsifiable. And it's independently verifiable. I like all that. Believe me, I like all that. So I'm going to make a prediction, and I want you to falsify it. I predict that since the Bible says the animals and plants will bring forth after their kind, I predict that every farmer in the planet, every farmer in history and alive today, will be able to count on crossbreeding his plants or animals and getting the same kind of offspring. The ducks will produce ducks, the cows will produce cows, and the corn will produce corn. That's my theory, that they will bring forth after their kind. And the word kind, apparently in the Bible, is tied to the bringing forth. A horse and a zebra can bring forth offspring. A horse and a banana cannot. A horse and a duck cannot. Now, exactly where the line is on all of those divisions of what a kind is, I'm not sure. I don't think anybody is sure. That would be a good field of research for science to get involved in. But I think a 5-year-old can tell you that a horse and an elephant are not the same kind. Now, it could be that the Asian elephant and the Indian elephant, Asian and African elephant cannot interbreed. I understand it's been done once and the baby died, but they did bring forth. So I think a 5-year-old would tell you that the Asian elephant and the African elephant are probably the same kind of animal as opposed to an elephant and a hamster. So I predict, and I'd like you to falsify it if you can. I think my theory is reasonable. It depicts reality, and it should be falsifiable. Okay, get something to bring forth something that's not the same kind. Let's have dogs produce something non-dog, or cows produce something that is non-cow, or pine trees produce something that is non-pine tree. You can do it in botany or in biology, whichever you like, in husbandry. That's my prediction. I think it's held true. All of science, all of history has demonstrated the Bible is exactly correct. The animals and plants bring forth after their kind. And then that appears 10 times in the first chapter of the Bible. In the flood story, chapter 6 and 7, it appears 10 more times. God told Noah to bring the animals onto the ark after their kind, after their sort. Now, Charlie Darwin wrote a book, The Origin of Species. I don't think that's what the argument is about. There's many different species that are obviously the same kind of animal. I think there are, 500 or 600 species of ladybugs now. It's a bug. It's recognizable as a ladybug. So they go by the number of spots or how long their legs are or how high they can sing in the shower. I don't know, but they're still a bug. And I think that the argument that the atheists and evolutionists are looking so desperately for evidence of variation of species, which is not really the argument. They bring forth after their kind. So you said the strength of a theory is that it depicts reality. The evolution theory, if I understand it correctly, says animals are all related if we go back in time. So if you go back in time, you think a crocodile and a duck are related, apparently, from your name, Crocoduck. Ultimately, and that is what the theory of evolution teaches, a crocodile and a duck are related if you go back. I'll give you all the years you want. You can go back millions or billions or trillions or quadrillions of years. Do you believe a crocodile and a duck are related? And what is the evidence for that? Nobody has ever seen a duck produce a non-duck or a crocodile produce a non-crocodile. You're living in dreamland. You would think it happened, you imagine it happened, but evolution is a religion that people believe in. It is not part of science. Real science is things we can observe, study, test, and demonstrate. And you're right. The theory should predict reality. The reality is cows produce cows and ducks produce ducks. That's the reality. And every farmer in the world will tell you that's what they observe. And in the laboratory, they can try frantically to get variations beyond that, and they fail. They have worked for years to get wide range of variety of dogs, for instance. And we now have Chihuahuas to Great Danes. Okay, that they're still obviously dog. And it could be, as I've mentioned many times in my seminars, dog, wolf, coyote probably had a common ancestor. I understand coyotes and wolves have been interbred. They don't like to and don't in nature, but they can. So the Bible definition of kind is having to do with bringing forth offspring. Now, whether the offspring are viable or not, it doesn't say. For instance, the horse and the ass bring forth a mule, which is 99.99% of the time sterile. I've heard that 1 out of 20,000 is fertile. I don't know, it doesn't matter to me. The fact is they're both four-legged animals, you know, four-wheel drive, leather upholstery. They both look like a horse. And probably the horse, the zebra, the ass, maybe the quagga, I'm not sure what all can be included in the horse kind, but it's obvious to a 5-year-old this is the same kind of animal. And a crocodile and a duck are not the same kind of animal. And they cannot be, you cannot trace them back to a common ancestor. Not with, by your definition, it should be predictable, it should depict reality. The reality is every native that grows up around crocodiles will tell you when they have babies, the babies are crocodiles. And when they open up the eggs to eat the eggs, if it's fertile enough and developed enough, it's a crocodile. There are simply no exceptions. You are living in a dream world. You have a religion which teaches you a crocodile and a duck are related, but that is something you believe. Now, I resent having to be forced to pay for that to be taught in the school system, and I think most people do. We are all being forced at the point of a gun to pay for your religion to be taught to all these kids. If you really believe a crocodile and a duck are related, you should go start a private school and pay to teach whatever you want to have your kids taught. Teach them anything you want in a private school, but I resent paying for your religion to be taught in our school system. So I think our theory is independently verifiable. Without warning at all, go to any country in the world, ask any farmer you come to, I promise you, I won't alert them that you're coming, and ask them what they get when they crossbreed, whether it's a plant or an animal, doesn't matter to me. If they're raising horses, say, when you crossbreed your horses, what do you get for a baby? I predict, sitting right here, and where am I at? Monroeville, Alabama, that you can go to Timbuktu, and the farmers there will tell you, yep, we cross our sheep, and we get sheep, and we plant our corn, and we get corn. I think my theory that they bring forth after their kind is extremely verifiable, and yours is completely unverifiable. Nobody has ever seen a duck produce a non-duck or a crocodile produce a non-crocodile. You believe it happened, and the textbooks teach it happened, and I can show you if you'd like, straight from the public school textbooks, hundreds of sentences where they say all animals are related. Charles Darwin said, it's a truly wonderful fact that all plants and all animals throughout all time and space are related. Now, Darwin probably really believed that. I don't question that he believed it, but that doesn't make it true. Many people believe oddball things. It doesn't make it true. Science deals with things we can observe, study, and test. We don't observe ducks produce non-ducks. And we can't project back in time and imagine anything. If we go back 1,000 generations or 50,000 generations, what was the ancestor of the duck? I would predict it was a duck, without exception. So I think we need to, if the moderator can do this, let's take one topic at a time. If you want to chase that one, is your theory verifiable, or is my theory verifiable? Is yours falsifiable? You could falsify my theory by having any animal or plant produce something other than its kind. I think your theory's already been falsified, because you predict by your theory that all animals are related, and yet you offer no evidence of that, no proof of that for sure. So you might twist some evidence to say, oh, this counts as evidence because look, you know, the pine tree and the oak tree both have bark on them, therefore they're related. No, maybe they're both designed that way. Okay, so science doesn't interfere with evidence. I agree. Don't interfere with the evidence. I won't interfere. Go to Timbuktu and ask every farmer you find there what happens when they crossbreed, whether it's plants or animals. I don't care, either one. So I think it's the evolutionist that is the one that interferes and is the one that has a stupid theory, stupid religion, in my very humble, totally unbiased opinion. If you want to believe a duck and a crocodile are related, you enjoy yourself. Do whatever you want to do. You can make your own YouTube channel and teach whatever you want to teach. But when it comes to forcing this stuff on the kids in public school, that's where we got to draw the line. If we should have public schools at all, which is another whole debate, they certainly shouldn't present one religion at taxpayer expense. But that's exactly what's happening. If someone refuses to pay for that, that's usually with house taxes on real estate, they come seize your house. You didn't pay your school tax, and they'll take your house away from you at the point of a gun. So all people are forced to pay for this one stupid religion of evolution to be taught in the school system, and I, frankly, resent that. I'm not trying to force creation into the schools. I never have. Teachers can already teach creation if they want, but it's not my goal to get creation into the schools. I want lies out of the textbooks, and I want religion, like evolution, out of the schools, unless they're going to teach all religions with equal time, which they're not going to do. So all of us are paid for one religion to be taught, which is yours, and I resent that. Let's see. You said scientists don't assume things, they make their observation, they try to match observations. Okay. Observation. Cows produce cows. All over the world, all through history. That's an observation. Make your theory match that, please. Okay? You said creationist, I think you said, I'm trying to write frantically as you read your speech very quickly. Both positions deserve equal consideration. I don't know that that's true. I don't know that you should waste time on dumb theories that don't have, just teach the truth. That's the truth, kids. We can teach the kids, hey, you got 2 bones in your wrist, radius and ulna. The whale has 2 bones in his flipper, okay? The hamster's got 2 bones in his forearm. And somebody named them radius and ulna. I doubt the hamster named them that, but somebody named all these bones in the forelimb of creatures, radius and ulna, and humerus. I agree. We do have similar structure in the forelimbs of nearly all mammals, maybe all mammals, even bats. But what does that prove is the question. See, observing something, oh wow, look at these similarities. That is a fact. Teaching anything beyond that, you got to be careful because that becomes your belief. In the movie, I've got slides, I could call it up later if you'd like. In the movie, The Green Mile with Tom Hanks, great movie, by the way. The fact is, the girls went missing. The fact is, John Coffey was found sitting with the 2 dead girls out in the woods, crying. The fact is, they arrested him for the crime. Those are facts. We observe that in the movie. The fact is, he didn't do it. But based on the evidence that they had, here's this black man sitting with 2 dead two dead white girls. They came to the wrong conclusion. He killed them when he didn't. It is totally possible. You talk about the courts of law. You're right. I don't have much respect for lawyers at all after what I've been through. But you're right. They don't care which position they argue. They're just good at arguing. And I think evolutionists are the ones that are doing what the lawyers are doing. They're good at convincing the kids, regardless of the evidence, convincing the kids that something happened when it didn't happen. So the lawyer should have looked into that case. The facts were the guy's caught with the dead girls. And the fact is he didn't do it. So they made an improper inference from the observation. And that is very possible. I think we can observe, and everybody observed, dogs produce dogs and oak trees produce oak trees. And if you want to infer something beyond that, be very careful because you're outside of science. But you guys seem to love to think that evolution is part of science. It is not. It is a religious belief that you may believe very strongly, and you're welcome to have it. But it's not science. So you sent a text that you'd like to talk about the 5 topics: the age of the universe, the Big Bang, radiometric dating, stellar evolution, and the speed of light. I would be honored to talk about all of those, any of those, one at a time. But I want you to try to see the bigger picture.
All right, Ken, you're at about the same time. Casey.
Okay.
Okay. So that, yeah, those your opening statement was a little more like a rebuttal, but that's fine. Casey, do you want to redirect a little bit? You did give him initially, if I'm not mistaken, those 5 things you wanted specifically to talk about, correct?
Yeah, and I said also in the opening statement, and I quote directly, "I've come to this debate with the understanding that the matters being discussed will exclusively pertain to the physical rather than biological sciences."
Okay.
So we agreed beforehand we wouldn't touch on biology. That's not my field. You know, I'm in physics. So I've come here to talk about physics. I will address one point that you made and just leave it there about the kinds thing.
Okay.
But first things first. Religion, God, it's nothing to do with this conversation. Whether or not the universe is 13.8 billion years old, whether or not evolution took place, has no impact whatsoever on on my metaphysical beliefs on whether or not the universe has a creator, and vice versa. If you convince me right now that there is a God, it would have no impact whatsoever on my views on evolutionary theory.
Okay.
So
Let me respond to that before you go off to a new topic. Let's start one topic at a time. Here's as many as you want, but let me answer. I think.
Hold on. You brought up a bunch of topics. Let me.
I was responding to your initial. Your initial.
Well, that was his opener. And by the way, I want to take the hit because for the whole evolution with creation thing that I said initially. Yeah, I didn't know exactly what the topic was. I was asking initially. I didn't have a good confirmation on that, so I do take the hit for that. Why did you address one specific thing at a time, though? Make it a little bit easier. Casey, I assume my voice is a little bit shot today. Please accept my apologies, but. What is one thing at a time you want to address with Ken, and then kind of go back and forth on that one for a while?
Well, I would like to talk about the age of the universe and how we know the Big Bang actually took place, and that it took place 13.8 billion years ago, as opposed to 6,000 years ago.
Okay. Give me your evidence that the universe is 13.8 billion years old, and let's talk about that.
All right, Hubble's law.
Okay, which is, describe that for the average viewer here to listen to Hubble's law. How would you define that?
V equals h naught times d. The velocity, the recessional velocity of the galaxies in the universe is equal to the Hubble constant times the distance to the galaxy. And this relationship was discovered by Edwin Hubble in 1929 when he was looking through the Mount Wilson Observatory telescope. Okay. What this tells us is that the universe is expanding. There's a redshift that is proportional to every galaxy, well, almost every galaxy. The ones that are close enough to us to be gravitationally attracted, those ones are blue shifted instead of red shifted. But all of the other ones, the ones that are too far for gravity to take over whatever is causing the expansion, those are red shifted, and it's all proportional to the distance. Everything is moving away from each other. Now, hold on. I'm getting to the 13.8 billion thing.
Okay.
Now, Einstein's general relativity was published in 1916, confirmed in 1919. And a few years later, the mathematician Alexander Friedmann played around with Einstein's field equations. Same equations that have been making basically all of these predictions that have been verified again and again and again. The most recent one was gravitational waves last year, 100 years after he first published it. So it's one of the most well-established theories in physics. You can't take down Einstein, basically. I mean, you could try if you want, but the point is the Friedmann equation, which comes from Einstein's field equations, which is directly derived from it, makes predictions about the state of the universe at different points in time. It tells us about how the state changes over time. And when you apply it to Hubble's law, you're able to derive the age of the universe from this equation. And that comes out to be 13.8 billion years.
Well, let me respond if you're done on that. I agree. It appears most of the galaxies are redshifted. That is an observation that I think is correct. I agree that this probably indicates the stars are receding. Those
galaxies.
Galaxies, okay, no galaxy. The stars are receding. I agree. Now, that is where the science stops and the belief or theories begin, and you have to be cautious about that. There's an awful lot of stars out there in the universe. On my DVD number 7 of my series, Creation Seminar Series, I cover this about the starlight problem or question. You are missing the entire point on this completely. It is true the stars are giving the galaxies are giving a red shift. Now, what does that prove? Just like it was true John Coffey was sitting there with the dead girls. That was true. What does it prove? It does not prove he's guilty of killing them. If the stars are giving a red shift, numerous things could be causing that. Primarily, I think the Bible says 17 times that God stretched out the heavens. If indeed the scripture is correct, that God made the earth first and then made the stars on day 4 and stretched them out into place, we would see the same red shift from all the galaxies being stretched out away from the earth, and could still only be 6,000 years old. He could have made them yesterday and stretched them out to 13.8 billion light years away. So they may be 13.8 or whatever number they're using this year, 13.8 billion light years away. Could be. I don't argue with that. Probably true. That does not mean it's 13.8 billion years old. Surely you know a light year is a distance. It's not a time. A light year has nothing to do with time. It's the distance that light travels in a year, about 6 trillion miles, or 182 point, well, you don't want to use 9.8 meters, whatever the number is in metric system. I can calculate it out. It doesn't matter to me. But nobody's ever seen a star forming. None. And I've got plenty of quotes I can show you on screen, or watch my video 7. Nobody sees one forming. We see a lot of stars. We see them blow up once in a while, and we do see the galaxies red shifting. Now, there are 2 options to that, at least 2. One is they are 13.8 billion years away, and it took 13.8 billion years for the light to get here. That's the only option you can see. The other option is they were stretched out into their current place, and they're 6,000 years old and 13.8 billion light years away. But even this, Casey, if the universe is 200 quadrillion years old, that doesn't help the evolution theory. We never see anything produced outside of its kind. So it doesn't.
Ken, we're not talking about evolution.
Okay, you're talking about the age of the universe. I think we have certainly a lot of historical evidence, from anecdotal evidence from people going back 4,000 or 5,000 years, and that's it. There's nothing beyond that. There's no historical proof that the Earth is any more than 4,000 or 5,000 or 6,000 years old. We see the stars redshifted. I agree. I think you're giving only one interpretation of how that could happen, and I think yours is wrong.
Okay, can I address that?
Sure, please do.
Okay. We come again to the same evidence, different interpretation nonsense, and this is the kind of thing I was talking about. Let's start with this Bible thing about how the Bible supposedly predicted the stretching of the universe. The verse you're referring to in Isaiah says that God stretched the universe like a tent. I don't know what this means, like a tent. I don't think that it resembles a tent at all, but it's irrelevant. I'm not here to talk about religion either. What I do find concerning is your view that we are able to see 6,000-year-old light from objects that are 13 billion light years away. That we can look at something. You correctly said that light is a unit of distance and not time. A light year is a distance, not time. But if you remember from 6th grade, you might remember this thing called the distance triangle. You have a distance, you divide it by the rate, the speed of light c, and you end up with the time. I mean, how do you think we measured a light year? Do you think that we took a ruler and we said, okay, this is how far? No, we multiplied the speed of light by the amount of time that's in a year, and we end up with a light year. So when we're talking about a light year, we're talking about the distance that light travels in a year. If light is traveled 1 light year, it has taken 1 year for light to travel that distance. These are all equivalent statements. This is what it means for it to be a light year. So when we say something is 10 billion light years away, we're saying that the light has taken 10 billion years to traverse this distance of 10 billion light years. There's a reason why it's called that. Now, if it is the case that the universe was stretched out and that God stretched out the universe and that these objects are now 10, 11, 12 billion light years away, and that we're seeing 6,000-year-old light, we have a problem here. These things should be redshifted into oblivion. We should not be able to see these things. In order to be able to see these objects 13 billion light years away, the evidence for it, the light itself has to show indications of being 13 billion years old, and you get this from the Hubble equation. You have to look at how redshifted they are and compare that to the Hubble time.
Let's slow this down. Take that one topic at a time.
You brought up like 5. Come on, Ken, don't tell me one topic at a time when you're bringing up like 5 things. You brought up stellar evolution. Don't play these games, man. Come on.
I brought up one point with the distance of the stars.
You brought up stellar evolution as well. I didn't even get to that.
Do we? One second, guys. Do we know who these other people are that are coming to the hangout?
Anybody?
No idea.
I don't know how the link is out there. I did not put the link out to anybody. Matthew Thomas.
Well, see, this is where moderator, we'll go one sentence at a time or one word at a time if you'd like, but he leaves a lot of points hanging that are going to confuse the audience into thinking he's right.
Well, let's stick with I mean, he brought up the fact of Hubble's law, Hubble's constant, and why that is indicative of an old Earth. Do you want to touch on that a little bit more specifically, Casey, and why that would be an old Earth as the only explanation, as opposed to Kent's version of a young Earth? A young universe, and why that could or could not be?
Ken's version. Hello. Yeah.
Go ahead.
Ken's version is physically impossible. You can't have light travel a distance of 13.8 billion light years over the course of 6,000 years. It's not possible. When you're saying that we're seeing these things that are 13.8 billion light years away, what it means is that light has traveled from these things a distance of 13.8 billion light years. If the light is 6,000 years old, we should not be able to see past a spherical shell of 6,000 light years, even if the universe is stretching. If the universe is stretching past that point, it becomes redshifted to the point where we can't see it in any spectrum. The 6,000 year shell becomes our cosmic horizon, and everything outside of the shell is expanding away from us faster than the speed of light. But that's not what we observe.
Okay, well, let me answer that. If a person, let's say a person is traveling in a car going 700 feet per second away from you, and the speed of sound is, say, 711 feet per second at that density, atmospheric pressure, et cetera, all kinds of things affect the speed of sound. Okay, so here's a person in a car blowing their horn as loud as they can. They're traveling away from you at 700 feet per second. After X number of seconds, we notice we can still hear the horn. After 4 seconds, we could still hear the horn. But now they're way more than using the speed of sound. Since they're going slightly less than the speed of sound, it's what's called the Doppler effect. I'm sure you're very familiar with that. Mm-hmm. So if the stars are indeed receding at a certain percentage of c, the value of speed of light, they could indeed still be 6,000 years old and be billions of light years away. You are completely missing the point.
So, I think you're misunderstanding the principle, Kent. The Doppler effect. Let me explain. The Doppler effect is comparable to the situation, but you have it wrong. When this vehicle is moving away from you and it's honking its horn, yes, the waves get stretched out. That is true, but the frequency with if you look at the actual Doppler equation, you're able to calculate the distance that the car is at. And it's the same general principle with the speed of light. This is basically Hubble's law. That's what the equation tells us. It tells us what the relationship is between the frequency of these redshifted lights is to the distance and the recessional velocity. It's same with the Doppler equation.
Okay, now slow down. No, you're saying we can calculate the distance that the car is away. That is only if you know what percent of the speed of sound it was leaving at. You don't know the speed of the stars were stretched out into place.
We can see the frequency of the redshift. We can see that the spectroscopy of the stars have moved by a certain amount, and that gives us the value for the frequency. Once we have that, all we need is the Hubble constant, and we're golden. We get the distances. Not even of stars. We're talking galaxies. We're talking intergalactic objects.
I didn't argue about the distances. I said I'm arguing about the time.
Okay, but this is related to time.
A light year is not a year. A light year is a distance.
Okay, Ken, let's try this again. If light has traveled for a light year, it has traveled a distance of a light year. How long has it taken it to travel that?
If it is traveling at 1 light year per second, then it's 1 second old.
Hold on. No, that's not my question. Let's say light has traveled a distance of a light year, yeah? How long does it take to get from the beginning to the finish line of this light year long racetrack?
With no other things affecting it, light would travel about 186,282 feet or miles per second.
And how long would it take?
It would take 1 year to go that distance.
Thank you, Kent. Thank you, Kent.
You're missing the point completely. Absolutely, completely missing the point.
You say that over and over, but you're not demonstrating it. Tell me, what am I missing?
Okay, how old was Adam on day 1? According to science, he was.
So you're using the Omphalos argument. Then you're saying that the universe was created old.
No, I'm not using that argument. I'm saying in order for it to function, it has to be created mature. There has to already be apples hanging on the tree for Adam to eat. He can't wait for them to grow from a seed. God had to make a mature creation because they're going to die if there isn't food. The whole system's already in place.
So that's what you're saying. You are saying that the universe was created to look old.
No, not to look old. It was created mature. To us, it would look old because that's all we're familiar with, is born at, small and grow bigger. But to them, it looked normal.
What is the distinction? What is the distinction between looking old and being old?
Well, it depends which one you are. To us, everything that looks old probably is old. To Adam and Eve, he looked brand new. And Eve looked brand new. But if God made the stars on day 4 and stretched them out into place, which is what it says 17 times in the Bible, then it could indeed be 6,000 years old and be billions of light years away. You don't get it.
Okay, I predicted this. This is Hovinding. I'm going to read again what I wrote. I predict, yeah, at the end, I said, I predict that whenever I corner Mr. Hovind on any matter, demonstrating how the rejection of a particular phenomenon results in a vision of the universe that is patently absurd, such as the universe being 6,000 light years long, my opponent will claim without evidentiary justification that the variables under discussion or the principles being rejected used to be different, that the laws of physics, for whatever reason, changed over time in such a manner as to make the universe appear to be billions of years old rather than thousands. Now, what you're saying is that through this invocation of magic, through this divine intervention, that in effect the laws of physics were different, that this stretching of the universe to its present size with the recessional velocities that it was stretched with, and which it continues to be stretched with, by the way, it hasn't stopped. Right. That this contradicts what the science says, and that there's this special case of divine intervention that makes it only look mature when in reality it's only 6,000 years old.
You're missing the point again. You did not corner me, by the way, at all. I did not reject any laws of physics. Instead of light, let's take it with sound. If a car is leaving us at 700 feet per second, but the sound from the car is traveling back toward us at 711 feet per second, is it possible for the sound measuring at the speed of sound to be different than the actual distance to the car, or to the time it took for the car to get there?
The frequency is going to be different, yes.
Sure, that's what the Doppler effect is all about when it comes to sound. It's the same with light. That's why we.
But the speed is not different, Kent. The speed hasn't changed. The frequency has.
Well, that's why we have a red shift.
Yes.
Doppler effect.
But he's saying that's due to a change of frequency, not a change of speed.
Is it?
Do you know what the difference is between frequency and speed, Kent?
I do. What if a star is leaving us at 1/2 the speed of light? Are the galaxies moving away from us? Yes or no? Are the galaxies moving? Yes or no?
The galaxies themselves are moving. But when we're talking about the expansion of the universe, it's more accurate to say that the space itself is
You believe, I believe, we both believe in the expansion of the universe. I believe it's happening. I can't prove it. I think it's difficult to measure those distances beyond about 100 light years with the trigonometry, but
you don't need parallax to make those measurements. You can use standard candles.
Right. Luminosity, that kind of stuff. Okay, but if the stars are 13.8 billion light years away, in your mind, the light had to start there to get here, when the reality is the star started here and went there, and Adam and Eve could see the taillights as they receded, and they could have been made 2 seconds ago and still be that distance out there if they were moving fast enough.
Okay, Kent, again, you're misunderstanding the physics. If the light, let's say the star started 6,000 light years away from us, and the light began moving toward us, and then God stretches the universe, and the light is now 13.8 billion light years away, say. And now the light, which started 6,000 light years away from us, is reaching us. Yeah?
I didn't say it started 6,000 light years away.
Let's say for the sake of argument that it started 6,000 light years away from us.
And that light would just now be coming on. I agree.
Yeah. And now we're looking at the light of a star that's 13.8 billion light years away, even though the light is 6,000 years old. Is that what you're saying?
That is one option. I don't know where they started from. All I know is the Bible 17 times says God.
Okay, hypothetically, it starts 6,000 light years away, and so we see light that's 6,000 light years old instead of 13.8 billion years old, even though the star is 13.8 billion light years away.
No, I disagree, because Adam and Eve could see the stars the first day. So they could not have started 6,000 light years away. Or he wouldn't have seen them. Nobody would have seen them till today. They would just now be flickering on in the universe. And we all know from history, people have always seen the stars. So I disagree. They started 6,000 light years away. But whatever distance they started doesn't matter. The fact is, you can answer the same problem of these great distances to the stars with either great age or a stretching of the universe.
Okay, but the answer is no, and I'm going to get to that in a second. But let's say they're a distance x away. Let's say they're 30 light hours away.
Here's for your theory.
Hello?
You have chosen to believe the stars indicate great age rather than stretching, because you need billions of years for your crocodile to turn into your duck.
No, this thing happens independently. This has nothing to do with evolution whatsoever. Even if Charles Darwin was never born and evolutionary theory never came to fruition, this would still be the case. People would still be talking about this. But the point is, you're completely wrong about this. Let's say that the star starts out at a distance of X light hours away. So that Adam and Eve can see it on the first day. Say it starts out 2 light hours away, and the light reaches Earth within 2 hours, and then God does this stretchy thing for whatever reason. The light that you're going to see corresponds to a star that's 2 light hours away. You're not going to see light that corresponds to a star that's 13.8 billion light years away.
Initially, as it recedes, the light would go with it and change.
Okay, as it's receding, if it's receding faster than the speed of light, which is necessary in order to achieve this kind of distance, it's going to be redshifted into oblivion, and you're not going to see it.
So, did you say if it's receding at faster than the speed of light?
According to your model, if it's receding, this thing must be receding faster than the speed of light.
I don't know what speed it was receding at. All I know is it says clearly God stretched out the heavens.
Now, Kent, hold on a second. If these stars were able to be seen by Adam and Eve on the first day 6,000 years ago, or on this 6th day 6,000 years ago, and then God stretched out the universe so that the same star, which was within, it was at the very largest distance, it must have been 6 light days away, right? Whichever day he created the stars, I forget which day was it?
The 4th day.
All right, so 2 light days away then, right? Between days 2 and 6, between days light 4 and 6, right. There's 2 days. So at the very greatest, those stars have to start out 2 light days away in order for the light to reach the Earth, in order for Adam and Eve to be able to see them. Then God stretches out the universe, and those same stars are now 13.8 billion light years away, supposedly the farthest ones. The speed with which they have to recede is many, many orders of magnitude greater than the speed of light. And for that reason, they have to be invisible.
We could spend all day talking about the calculation of how you get this 13.7 billion, if you'd like. Would you agree that that number down for the last 100 years has shifted all over the scale? I have textbooks that show it at 20 billion. I have textbooks that show the universe as 156 billion light years across.
Are you familiar with the concept of an error bar?
An error bar?
Yeah.
I'm in several different applications. What are you referring to it in?
Well, when I'm talking about error bars, I'm talking about in data analysis. You have a point on a graph.
Yeah, plus or minus. Right.
Yeah, plus or minus.
Sure.
So in all of these cases, or the overwhelming majority of them, there were a few mistakes. In the beginning, Hubble did famously make a mistake with regard to Andromeda, but wherever the same calculations were applied as they are today, you have these big error bars because the instrumentation back then wasn't as good as it is today. Those error bars encompass the current data points, and those error bars over the years became smaller and smaller and smaller. You said back in 1989, for instance, the textbooks were saying that it was 20 billion light years. And then it was something like plus or minus 10. And right now we're at 13.8 billion light years, and it's plus or minus a much smaller error bar.
Yeah, 16 hours and 6 seconds or something like that, right? Okay.
I don't remember the exact amount, but the point is as time goes on, our measurements become better and better, and the error bars become smaller and smaller. So what you're seeing here isn't something jumping all over the place. We're zeroing in on the correct figure.
Okay, what is the width of the universe? What is the diameter of the observable universe?
The observable universe, that would just be the Hubble distance. It would be, well, actually, it depends on the type of universe we're living in. If we're living in a flat universe, then it's going to be exactly 13.8 billion light years radius. If we're living in an open universe, which it appears we're in a slightly open one, then it could be bigger. If it's a closed universe, which it looks like it's not, then it could be slightly smaller. So it depends. Again, you have to look at the Friedman equations, you have to do the derivations, and you have to look at the experimental data and see which one most closely matches.
I have an article from space.com. It's from 2006. They locked me up for 9 years, so I can't update all 7,000 of my slides as rapidly as I'd like. But they're saying the universe is 156 billion light years wide. It says the new finding implies the universe is instead about 15.8 billion years old, and about 180 billion light years wide.
Okay, is this a popular media outlet? Because these matters...
Space.com.
Yeah, that's a media outlet. It's a science popularizer. These matters are not decided in the media. The media, you know, I could point you to articles. Every week I go on to Yahoo News and I see a new thing about how all of physics has been overturned by this new discovery.
Right. Sure. Okay.
Yeah.
And
so
even in the science journals, they get overturned quite frequently, and you can't even always count on that. And go back and read one 50 years ago, and you'll see some amazing changes from today.
Well, of course, but it depends on what field we're talking about. If we're talking about something like electromagnetism, we're not seeing huge changes over the past 50 years. Maybe some developments in optics, but for the most, and quantum electrodynamics, of course. But other than that, you know, Maxwell's equations are not changing over the past 50 years. Quantum field theory, on the other hand, is. So, you know, it varies from field to field. You can't make a sweeping generalization based on this. And cosmology is a relatively new field. It's only well, modern cosmology, like I said, was 1929, so we're less than 100 years in, and they've done a great job. The predictions are great. The models have failed to be falsified. You know, Big Bang cosmology has it.
Sure, and I love cosmology. I love the study of the stars. Love that kind of stuff. I think the assumption, the conclusion is wrong, but I'm not against the study or the scientific aspect. This article you mentioned is from space.com is researching, let's see, a research team led by Alceste Bonanos at the Carnegie Institute of Washington has found, let's see, a galaxy M33 is a 15% further away from our Milky Way galaxy than previously calculated. Currently, most astronomers agree the value of the Hubble constant is about 71 kilometers per second, per megaparsec. If this were smaller, let's see. Anyway, the article says the universe is 156 billion light years away. It was 156 billion light years across, and it's now, with this new 15% difference, 180 billion light years wide. So if the Carnegie or the Smithsonian, I'm sorry, what did I say? Carnegie Institute in Washington is claiming the observable universe is 180 billion light years wide.
Wait, observable or the universe? Are they using the word observable?
Let's see. They're saying, no, they don't use the word observable.
Okay, it's a different story then, because in principle,
no, very different. Same with biology. Observable is cows make cows. Okay, that's observable. Okay, nothing else.
No. When we're talking about the observable universe, we're talking about things that are within the cosmic horizon. So let's say we're looking at a star that appears to us to be 13.8 billion light years away. It took 13.8 billion years for the light to reach us, but in that time, the star has receded past the cosmic horizon, and we're not seeing it as it is right now, and we can't see it as it is right now. There is going to come a point where the star will simply disappear, because at that point, it's going to be redshifted into oblivion. It's outside of the cosmic horizon, so the recessional velocity relative to us is greater than the speed of light. We're not going to see it. Things outside of this horizon are outside of the observable universe, but they're still part of the universe. And you can see things that are currently outside of the observable universe, but you're not seeing them as they are right now. You're seeing them as they were many eons ago.
Or seeing them as they were 6,000 years ago.
I'm telling you, Kent, you can't do that. In order to do that, you have to make it go faster than the speed of light. We would not be able to see it.
Well, if indeed this article from the Carnegie Institute is correct, and it's 180 billion light years wide, that's 11 times faster than the speed of light for the star to get there.
Okay, but right now, where it's going, where it's at right now is different from where we're seeing it at. Like I said, you could be looking at something that's 10 billion light years away, and the light has taken 10 billion years to reach us. But as it is right now, in order to be able to see it as it is right now, you have to wait 10 billion years and wait for the light coming out of it right now to reach us. But by that time, it's already past the cosmic horizon. By that time, it's already way over past the cosmic horizon where you're saying it's at. And yes, we would not be able to see it as it is right now. But when we're looking at it right now, we're not seeing it as it is right now. We're seeing it as it was 10 billion light years ago.
I understand all of that. But if the universe is indeed 180 billion light years across, as this article says, that's 11 times faster than the speed of light to get there from here or from anywhere.
Yeah, it's outside of our cosmic horizon. Everything outside of the cosmic horizon is going to be receding faster than the speed of light.
Faster than the speed of light.
Yeah.
if I got your quote right on this. Everything outside of our cosmic horizon is receding faster than the speed of light. That's what you.
Yeah, though I should argue that it's not the object themselves that's moving; it's the space in between that's moving faster than the speed of light, which is fine.
Is the speed of light constant in all times, all through space? You're just done saying the speed of light is faster outside of our horizon. Could it?
That's not what I said, Kent. That is not what I said. I said that the recessional velocity is faster than the speed of light. I did not say the light is moving faster than the speed of light.
Okay, so the object, the mass, the actual.
No. Again, it's not the object that's moving faster than the speed of light. It's the space between the objects that's moving faster than the speed of light.
So is the star moving then?
The star itself is probably orbiting around another star. Maybe it's pulling on the other planets, and the planets are pulling on it. In that sense, it's moving. But the stars and the galaxies are not shooting away from us. We're not all shooting away from each other. It's the space between us that's expanding.
And how is this happening? Where's this energy coming from? And what evidence is there for this?
This is basically Hubble's law. This is what the entire theory is saying. The alternative would have to be that we are at the center of the universe, and apparently we smell really bad or something, because that means all the galaxies are running away from us by some mechanism that contradicts everything we know about gravity and so on. Okay. But in reality, we have space that's expanding faster than the speed of light, and Einstein's equations are completely fine with that.
If the space between the objects is expanding, then the object is getting further away from each other. If you and I were standing in a room 10 feet apart and the space between us expanded, we would move.
Not necessarily. The space between us is moving. The space between us is moving. In the classical sense, we would not be moving away from each other. Relativistically, relativity is a very different animal than classical mechanics. Well,
you're trying to say the stars are 13.8 billion light years away. Therefore, it took 13.8 billion years. Maybe they're 2 minutes old, and the space between them expanded to 13.8 billion years, and it did it
in that case, you wouldn't be able to see them.
Well, maybe there's a lot of them we can't see.
No, but you would not be able to see them right now. The star that supposedly was 2 minutes away from us and then suddenly shot away, we should be able to see the star that's 2 light minutes or light years away from us. And then when it shoots away from us, it should become invisible, because at that point it's moving faster than the speed of light in order to be able to reach those distances in that amount of time.
So if an object is moving faster than the speed of light, the light from that object will never reach us. Is that your observation?
Yeah, if it's outside of, that's what it means for it to be outside of the cosmic horizon. The recessional velocity, the space between us is expanding faster than the speed of light, and the light coming from them is not able to compensate for this expansion of space. It's never going to reach us. It's redshifted into oblivion, which is what I mean by that.
Where is this energy coming from to expand space between them?
Beats me.
I'm sure it does. This is purely theoretical, hypothetical. Is this
no? We are able to make all kinds of predictions with it.
You can observe space between 2 objects expanding, which I would assume would take a whole lot of energy. I mean, I can't think of anything else. And how do you do this without the mass moving? You have mass accelerated beyond the speed of light. The star is made out of material. Do you agree with that? There's some kind of mass to a star.
Yes, but it's not the mass itself that it's accelerating. It's the space between the masses that's moving.
Does anybody on planet Earth understand that, or is this just words that you're speaking here?
Intuitively, nobody understands it. We're talking about relativity here. When you're talking about modern physics, when you're talking about relativity and quantum mechanics and particle physics, there's no way of intuitively grasping these matters. Even now, we're talking to you about this in ordinary language. I'm only conveying to you a very superficial picture. We have to be talking about non-Euclidean tensors. We have to be dealing with differential equations. And in the case of particle physics, we have to be dealing with group theory. But at that point, it's going to sound to most audiences like gibberish.
The idea that the space between them is expanding, but they are not moving.
They could be. They could be moving. I'm sure they are moving. They're just not moving in the same way. So
faster than the speed of light. Hello.
They themselves are not moving faster than the speed of light. It's the space between them that's moving. There's a difference.
I don't think anybody in the world is going to see the difference here. Okay, if the space between me...
Well, they need to learn relativity. I don't know what to tell you, Kent. General relativity is probably it's one of the most firmly grounded theories that has ever been developed. It has yet to be falsified. It has yet to come out with a bad prediction. Like I said, it's been predicting things 100 years on. If you don't like general relativity, tell you what, Kent, you learn differential geometry, you learn tensor calculus, you go ahead, you look at general relativity, you find the problems with it, and then you go and collect your Nobel Prize.
Okay.
If you think you can take down Einstein, go for it, man. But I'm just telling you, this is the current state of scientific.
That space expands without the mass moving has been taught for 100 years, and Einstein said it, therefore it's got to be true, and nobody's taken it down. That doesn't prove it's right. Doesn't prove anybody even. You don't even understand it. How can
Yes, I do. I've studied this.
Okay, then explain to me how the stars move. How can the space between them expand and it not move the mass of the star? Where is this energy coming from to expand the space?
Okay, the energy itself we know very little about. We just give it this name, dark energy. We say it's a negative pressure gradient, and that's basically all we know about it right now. This is at the frontier. This is at the frontier of modern physics.
So a negative pressure gradient.
That's all we can say about it right now.
Bang, explosion. I think we use negative pressure gradients on Afghanistan and Iraq and all those places when we drop a bomb. Creates a vacuum as it expands out. I understand. Okay.
What?
Well, any explosion.
It's not an explosion. It's a constant. Well, not really constant. It's a parameter given by an uppercase lambda. Actually, Einstein was the first person to come up with this idea of a cosmological constant of a dark energy. He put it into his equations for general relativity as a sort of fudge factor in order to correct what he thought was a stupid thing. He thought it was stupid initially for the universe to be expanding. He thought the universe should be a steady state, so he put this extra term in to keep things expanding to counteract the gravity that was pulling things in, keep everything steady, put everything in equilibrium. But then later on, Hubble, discovered the redshift, and Einstein was like, "No, this was my biggest blunder. I should not have put that term in because I could have predicted the expansion of the universe." But then it turned out when people started studying supernovae and they began studying other things and looking more closely at the Friedmann equation and the results of COBE and WMAP and so on, that the universe is actually accelerating. It's not slowing down as people thought it would be. So this thing, dark energy, it's like a 10-year-old idea at this point, 10, 20 years old. People have been looking into it, and it's very young. There's a lot to be learned, but we don't know much about it at this point. That's the honest answer, and yeah.
Okay, Santa Claus and Easter Bunny are much older ideas than that, okay?
What's your point, Kent?
Fairy tale, okay?
Well, what's your point?
Dark energy. Now, think what you're doing. You're saying, I'm not saying it, but said it, you're implying clearly, the Bible is wrong. The Earth cannot be 6,000 years old because of an unknown force called dark energy, which expands things, and nobody knows where this comes from or how it works, but everybody better quit reading their Bible.
It's not because of dark energy. Dark energy is just the name that we give to whatever is causing this acceleration.
It's not observable.
Well, the reason the creation myth is wrong to say that the universe is 6,000 years old is at least in part because of Hubble's law, because we're able to derive the age of the universe using this principle of recessional velocities and the relationship to the galaxies.
That is not, you're not able to derive the age of the universe. You're able to derive the distance.
No, you can derive the age. It's a very easy equation, 1 divided by the Hubble constant. You can do it yourself right now if you want.
You're back to completely missing the point. A light year is a distance. It is not a time.
Did you hear that, Kent? That was me face palming. I mean, how many times?
Do it a couple more times, please. Okay.
How many times, Kent? Let's try this again. Let's imagine a racetrack that is a light year long. Okay? Light is traveling at the speed of light down this racetrack.
Okay.
It is a light year long. How long does it take for it to get from the beginning to the end?
1 year.
There we go. Okay, let's say the track is 2 light years long. How long is it going to take for light to get from one end to the other?
2 years, if it goes at...
Let's say it's 20 light years long. How long will it take?
Yeah, we can pick every number in the solar system if you'd like. Go through this as far as you want to count. I understand, but you're missing the point. If a light year is a distance, about 6 trillion miles is rounded off to that. So suppose somebody was a light year away and they fired a bullet at us at 10 times the speed of light. How long would it take the bullet to get here?
The bullet is flying at 10 times the speed of light?
It would take 1/10 of c, or 18,000 years to get here, or something like that.
If that was physically possible, fine, whatever.
You're saying space between the stars is expanding. That's not physically possible.
Yes, it is. Space doesn't have mass.
But the star has to be moving. The star ends up further away than it started. You got two stars X distance apart. The space between them expands. They are now further apart. Think about it.
Yes, I understand that. We're talking about relativity at this point. It's different from Newtonian physics.
Where's the scientific evidence? And the bigger point you're totally missing is none of this matters when it comes to evolution, because you're only getting over the first hurdle of trying to get billions of years to rescue a dumb theory.
I already told you, Kent, it's completely irrelevant. Even if we didn't know anything about evolutionary theory, this would still be a thing.
Okay, I don't think you've proven that the universe is billions of years old. I think we probably agree the stars may be 13.87295 billion light years and 20 seconds away.
Okay, now let's imagine a racetrack going from those stars to us. How much time will it take the light to reach us from the beginning of that racetrack to the finish line where we're at?
From where the star is right now at 13.8 billion light years away, it'll take 13.8 billion years for the light to get here.
Very good.
I got it, but you don't get it. How long did it take the star to get from here to there? What if the star was leaving us at 80% C?
Can't happen. It can't happen. If it did happen, Kent, then it would mean that it was moving at faster than the speed of light at that point, and we would not be able to see it right now.
The star is moving at half the speed of light, for the sake of an example, and
it's not going to get to that distance in time.
Do you agree a car can blow its horn and drive away from you, and you can still hear the horn as long as the car stays under the speed of sound?
As long as it's under the speed of sound, yeah.
You could still hear the horn blowing.
Sure.
Now it would drop the pitch, just like the Doppler effect. If any weighted a train track, you hear the as it goes by, the pitch drop. That's a simple Doppler effect. We assume this happens with light also, which is why the redshift theory comes into play. But the star could be 13.8 billion light years away and still be 6,000 years old. I don't see how you can't see it.
We would not be able to see it, Kent. We would not be able to see it.
Go out at night. Come here to Alabama. You can see the stars like crazy around here.
You would not be able to see it. If this expansion had taken place, that means that the star was moving faster than the speed of light by a factor of a zillion.
Okay, suppose there is a dark matter that is indeed expanding the space between the stars.
You mean dark energy?
Or dark energy. Well, it comes from dark matter, I thought was the assumption.
No. The two are completely unrelated. They have nothing to do with each other.
Suppose there is a dark energy that's expanding the space between the stars, and this has been going on for 6,000 years, and they now are 13.8 billion light years away. Just the space between them expanded. Bible is still true.
But we would not be able to see them. If it had expanded, okay, we're saying that the star was 2 light days away from Earth at its starting point, at the very farthest away. And Adam and Eve saw them 2 light days away. And then God suddenly stretched them way out, and he's stretching them out faster than the speed of light. The moment God starts stretching them out faster than the speed of light, that's it. They become invisible. They leave our cosmic horizon. We don't see them.
Okay, we have gone an hour and a half is what we scheduled for the debate. This is wonderful. We can do this every day if you'd like. Your first point about the age of
we can make that happen.
Yeah, the age of the universe and the Big Bang. I think we could ask the audience to vote if you'd like. I don't think you have proven it is billions of light years old. You have demonstrated that you believe this, and the indicator of the speed of light. I think there are other ways to interpret it. John Coffey did not murder those 2 girls.
There are no ways of interpreting it where you can maintain the laws of physics. In order to interpret it the way you're interpreting it, you have to believe that it's possible for something to be moving faster than the speed of light and yet not leave our cosmic horizon. And you have to invoke this supernatural nonsense, as opposed to just looking at what we're observing. You're shoehorning God in. You're making the model less parsimonious because you really want to save this God is stretching out the heavens thing. Maybe he did. I don't know. But the evidence doesn't say so.
Casey, you are the one who is violating the laws of physics with your expanding space between 2 massive objects.
No, that's just relativity.
You have the mass moving it faster than the speed of light. Somewhere along the line.
No, you don't. You do not. It's not the mass that's moving faster than the speed of light. It's the space.
So does the mass move? Does the star end up further away when this mass is done expanding?
Okay, I want you to imagine. I'm going to explain right now. Imagine a coordinate system. Imagine a grid. Yeah, and we're going to draw this grid on a balloon.
Okay.
Now we're going to draw 2 points on this grid.
I understand. I taught physics myself, but see, this
and
is.
Then hold on. We're going to start blowing this balloon up.
I know you're.
Now hold on. These points are still at the relative locations on the grid. They're not moving with respect to the grid itself, but the grid is expanding, and so the points are moving away from each other, and the speed at which they move away from each other is increasing as the balloon gets bigger and bigger. So the points themselves are not actually moving faster than whatever speed with respect to the grid. The grid itself is what's moving. That's the distinction that you're not getting.
Oh, I don't believe you. I understand that completely, but you're not getting it. This grid is on a two-dimensional surface, a flat surface, relatively flat, the surface of the balloon. It's expanding into three-dimensional space, and the points on the balloon are moving. Measure them.
They're not moving with respect to the surface. That's the point.
But are you saying the universe is flat and is a surface and is expanding, or if it's already starting off 3D? How are they moving? Into what? Into 4D or 5D? Where are they moving into? Your balloon is moving from 2D to 3D, which is why the analogy collapses. But the points on the balloon, you can measure them at 1 inch apart. Below the balloon up, they're now 4 inches apart. The dots moved.
But the points with respect to the grid have not moved. You need to understand, what's not allowed is on the grid, the point cannot move from one point on the grid to the other, regardless of whether the balloon is blown up or flaccid. The dots cannot move, say, more than 3 grids per second. That's the constraint. That's our analogy to the speed of light. But if the dots are completely still and the grid is expanding, then they are moving away from each other relativistically. They could be potentially moving away from each other faster than they would be if the dots themselves were traveling more than 3 grids per second. But the dots themselves are not actually moving. That's allowed. What's not allowed, again, is for the dots to be moving more than 3 grids per second.
You understand your balloon surface is two-dimensional for relative speaking purposes here.
What's your point?
3D. Where is this universe expanding into? It's already three-dimensional.
Well, could be more dimensions.
Okay, but you see, you're making this stuff up. This isn't science. This is religion. This is fairy tale stuff, and it may be true.
This is just interpretation of the observation.
The observation
it's an inductive inference. This is how science works. And it has accurately predicted all kinds of things. We have accurately predicted the distribution of the elements, and helium in particular. We have accurately predicted the oldest ages of the stars and the error bars that they should fall within. We have accurately predicted all sorts of things. I could pull up a whole list. I mean, the Big Bang Theory is one of the best vindicated theories in the whole of science.
Well, I think the Bible accurately predicted that in the last days there would be scoffers who would be willingly ignorant of the creation, the flood, and the coming judgment.
No. Hold on, Kent. Are you telling me that a book full of supernatural and outrageous things said that people would be skeptical and scoffing it?
The Bible talks about you, but hey, I'm here to rescue you. I'm here to help you get ready for that judgment day.
Man, I'm good. I'm good, man.
Okay.
What I'm here to do, I'm not here to do the religion thing. I'm here to do the science thing.
Me neither. I like science, and I'm not into religion. I'm into relationship. I know the God of the universe personally. He's my buddy. Hey, let's do this again. We'll get on to the secretary and schedule a time.
Sounds good.
And we talk about the 8. You want to stick on these same 5 points. I did not have an introductory speech written out like you did, so I'll see if I can get some stuff together. But,
sure.
And you can go first again if you'd like. But
you can go first. It's all the same to me. Whatever you like, Kent. Thank you for joining us.
Let's book them, and you keep studying. You keep climbing that mountain of truth. I'll wait for you at the top. Okay?
Yeah, we could definitely do that. Guys, I want to thank both of you for joining us. I think this was actually very interesting. I know we had a lot of people watching this. I appreciate everybody subscribing to my channel. Anybody wants to join the Great Debate community, where you too can actually join in and have debates like this and actually be part of the panels when we have these types of debates. The link is actually in the video description itself. I want to thank Ken Hovind, and I want to thank King Crocoduck. We'll get together and we'll schedule a time when you want to continue this. I love the talk about general relativity. It's one of my favorite subjects, even though I'm not anywhere near as versed in it as KC is. I've been reading about it since I was in high school, and it's a fascinating subject. I'm going to have a little after hangout after this. Anybody's welcome to join. It'll be an open link. I can hold 25 people in my hangouts. So that's going to be taking place in about 15 to 20 minutes after this hangout ends. But I do want to thank my guests. It was a great debate, and we look forward to when you guys can get together again and have part 2 on this. Okay?
Great. Thank you, sir. Tell the folks, go to drdino.com, my website, and King Crocoduck can advertise his, or my YouTube is just Kent Hovind Official. Everybody's invited to tune in there.
And Casey, do you want to put a plug in for your channel as well?
Yeah, come visit King Crocoduck. We do all kinds of debunking of pseudoscience there.
All right. Thank you guys for watching very much, and we'll see you guys next time.